Hello, everyone. Welcome to week 8 of AI engineering broadcast. Yeah, let me start sharing my screen. Today, we're going to talk about chapter 8 on dataset engineering. So what is dataset engineering? So this is about we provide high quality training data to fine-tune our model. So the goal is that we want to train the best model possible, ideally within our allocated budget, because it's very costly to curate a data set. It requires not only labor, but sometimes system and pipelines, as well as other costs related to find and have this data set in your database. And also the general trend right now is that data as the differentiator of the AI performance. Many companies actually have their competitive advantage because of the data. For example, they might have their proprietary data that the competitors don't have, which gives them the advantage. Or maybe they have the exclusive partnership with the clients so that the client sensitive data are becoming their advantage because their competitors might not have access to those data easily. So this is gives to a new term, which Andrew Wu also had a talk on the data-centric AI. So the idea is that we want to improve the AI performance by enhancing the data. So this differs from the traditional perspective of model-centric AI, where you see a lot of researchers and big companies will always try to build models with more parameters and more powerful. But the idea here is that also probably more opportunities is that the model itself will always get better and better by these open AI and large tech companies. But for a lot of smaller companies, you don't want to invest GPU and make the model itself better, but you much better by spending time on creating better data set so that the model response will probably be better and give you the competitive advantage that you can build your business on. So what is data curation? So it requires understanding how the model learns and what resources are available to help it learn. So training data ideally should exhibit the behaviors you want your model to learn. So this is just like teaching a kid about the society or the behaviors. So you want to show them the good examples to follow and the bad examples to not conform, so that in the future they can make their best decisions on their behalf. And there are three main criteria that we can use as a North Star. So the first is data quality, second is data coverage, and the last one is data quantity. And in the next few slides, each criteria will be talked in detail. The first one is quality. High quality means the data will help you do your job efficiently and reliably. So how do we think about quality? So there are 6 characteristics that we can measure quality. So the first is relevant. So the example should be relevant to your task. Say you want to train a model specifically for English and Chinese translation. But if say in the data set you have it's more for French and Japanese translation, and then they are not very relevant. The second is aligned with task requirements, such as factual consistency, creativity, and formats. Say you are training a legal model, you definitely need the examples to be very accurate, while you train a more creative one, like to help people brainstorm ideas or generate some very fancy pictures, then the training data should also be kind of more creative. The next is consistent. You need annotation of the labeling guideline. So this means in the examples, say if the score, the guidelines say it should be between 1 to 5, you should want all these annotated labels to follow this guideline. You don't want to have some of the score of 3 and some maybe 96, for example. It also needs to be correctly formatted. And some common mistakes could be trading white spaces, new lines, inconsistent casing, and numerical formats. These are all very common issues in data, as I saw when I was working as a data engineer. So the similar here is that data could be somewhat formatting issues. For example, there are different ways you can format some certain names. There are human readable format, uppercase, camel case, and so these the model might consider these are the different things, even though you want it to refer to the same thing. The next one is unique. So duplication can introduce bias and cause data contamination. So this means that, let's say if the data is about certain objects and there could be different records pointing to the same one. And if some groups are overrepresented because there are more duplications for that group, then there will be bias from the model response. The last one is compliant, especially on the laws and regulation regarding PII data or the data which requires certain access. The next one is data coverage. So you want the data to cover the range of problems you expect it to solve. For example, if you are fine-tuning a model internally for answering employees' question, so in that case, usually you will have the internal documentation such as HR, payroll, leave policy, etc. But you need to define the problems that wanted to solve. For example, you should want only restrict it to this HR-related question, but not so much on career growth-related question. If that is not the intended problems that you want that particular model to solve. And from the research, the author mentioned the high-quality code and the math data is more effective than the natural language text in boosting models' reasoning capabilities, because code and the math are really easier to be evaluated. And you also want to choose a data mix that accurately reflects the real-world application usage. There are more details on the data mix, especially using the example of training Llama 3 example in the book. Last one on the criteria is data quantity. So basically this means how much data we need, right? So in theory, more data would be better, holding, say, if we hold the quality and the coverage the same. But there are some other factors besides from quality and diversity. The first one is that what technique you use to train fine-tune the model, as we discussed last week. The next one is the task capacity. If it's more complex, and you probably will need more data. Just like as a human being, we learn certain things. If something is harder, it will probably means we need to learn that more times. But I think this is a very good example because I'm right now learning, say, kickboxing, which is to be pretty complex moves. So usually I need to watch the instructor several times before I can fully understand these different moves. But versus easier task, such as say cooking a simple dish, I can just generally follow by very simple after a few times by watching the video. So the capacity also means if whether we need more data and different examples so that the model could learn that task. And the last one is the base model performance that we fine-tune our model on. Because if the base model is already pretty good enough, and then we would need probably less data than a less capable base model. And really, if you only have a small amount of data with restriction, you might want to use a PEFT method we discussed last week, parameter efficient fine-tuning, a more advanced model. But if you have a large amount of data, then you probably can try the full fine-tuning with smaller models, because the data size is not your bottleneck anymore. And also on the quantity is that we want to have the diversity within these quantities as well. So how do we think about diversity? Basically, it means we want to make sure different groups or categories of the data are well represented. For example, task types for summarization and question answering. So for the documents, there could be different types, but maybe some of the types are more dominant, some are not, and there could be different kind of response that we want to make the model to summarize or do the QA on these documents. So we want to make sure you have the good amount of data on the least amount of the type category, so that it can also do pretty good summarization job on these types. The next one is the topic diversity. If you want to find a general model, you want to have a lot of different topics. And also that, back to the earlier point, depends on what kind of task you want the model to be. And also the expected output formats as well. Next, we're going to talk about acquisition and annotation. So basically, when you say you want to start a project or even a startup, the first thing definitely the first thing is that you know what problem to solve, and then you will need to figure out how to acquire the data. And usually this could be either, say, from open source public data. But with the public data, the issue is that probably these are already pretty well studied and used by other companies or studies. So it will be super difficult to just build a company or unique advantage by using this data that other people can also easily have access to. And the next one is paid way. So basically you can buy those data. So there are a lot of data vendors. So one example I used look into in my side project before is about the job postings. So because it's very difficult to web scrape the LinkedIn or Indeed data, because they have the system to kind of protect against scraping the data. But there are a lot of data vendors out there. Basically, you can pay to buy those job posting data from LinkedIn or other places, either by the number of the data or the monthly subscription. So that's also a way where you can acquire data. And the book talks about a very popular concept right now. It's called data flywheel. So this it just means a iteration cycle where you get and store the user's data from the applications you have so that you can retrain the model or improve the user experience by these user or system generated data. And this is very closely related to another term called human in the loop, where because if you just provide a UI experience and the model is very generic, you cannot really provide a very personalized experience. But data flywheel means that each user will have their choices and decisions or actions they made on your web app, and then using these user action and behavior data, you can further customize their performance and also personalize the AI's response to them. So this is also very user content. This could be user content, system generated data from user usage or the user feedback. So when building an AI product, it's very important to have this in mind, where how you can embed the data flywheel by capturing those data. For example, you can have some buttons or text box where you then can type, and also for the basically the baseline is that you just don't want to simply show the AI response and presuming that they will like it, because probably they will have a lot of opinions. You want to have a way where user can provide you with the feedback, whether they like that response or don't like, and the reason why they don't like it. So this is super helpful because it's just like a machine learning, and then you can retrain the model and make the model better using those feedback. And also, no matter the data is acquired or annotated by the data labelers, you want to thoroughly inspect it and validate the data before using it for fine-tuning. Because as we mentioned last time, fine-tuning a model is super time-consuming and costly to do. So you don't want to redo that at the middle when you realize that the data has a lot of issues. You also want to have an annotation guideline for both manual and AI-powered evaluation for the annotations. So essentially, this is that you don't just want to casually check out the data to see if it's good or not. You need to define what the acceptance criteria when you look at those data. The next topic we have is data augmentation and synthesis. So why is this topic important? Because from here, you can see that data is, well, the real data clean, well formatted, will just not happen or easily available to you, right? Given the limited budget. So that's why a common technique is augment or synthesis the data set. So augmentation means you create new data from existing data. Synthesis is generate the data to mimic the properties of real data. So these will help to increase quality, coverage, and quantity, as we mentioned earlier. And can also mitigate the privacy concerns because, for example, the PII data, the people's medical records, if we cannot use them, but we want to train a model that could, say, interpret those medical records, then we can synthesize the data by mimicking the properties of the real data. So the example here is that maybe we cannot use people's name, address, or the other personal information on that medical records, but we can, say, use the doctor's notes in these documents. So by synthesized data is that, say, we can generate basically fake name. Say if we want to somehow preserve the gender and the race of the name, but not the real name. For the notes, we can also kind of like use AI to rephrase the language so that it does not 100% the same with the original paragraphs. The last one is distilled model, which will be mentioned that later. And there are both traditional and AI-powered ways to do data synthesis. So traditionally is that we can do rule-based, based on this rule to generate the new data and also simulation. But the more common way, which give a lot of people a lot of new opportunities, is the AI-powered synthesis. So it can use AI to simulate humans, like to create a game. So one example is the use AI to play games like chess, so that it can simulate a lot of the moves by the human player and what are the potential outcomes from that. And then AI can also do paraphrasing and language translation or code translation as well very quickly. Also, it can generate data for both pre-training and post-training. So once you have this synthesis data, it's very important to verify them. So you can check out our earlier chapter on the evaluation framework. So both by functional correctness and AI judges. Usually the coding related examples are among the most commonly synthesized data because it can be most easily verified by just running the test and the code to see if it works or not. And the AI verifier is also very common used right now as a general purpose AI judge. However, there are also limitations to AI generated data that we should keep in mind. So the first one is quality control, because data model could hallucinate. So we need to develop the reliable methods and metrics to evaluate data. The next one is superficial imitation, because the generated data could somehow missing the factual accuracy. And the next one is potential model collapse. So what this means is that this AI generated data might somehow have the issue where it can cause irreversible defects in the resulting model, such as over-representing certain data group. And this way, as we train and reiterate, the model could lead to a lot of the biases. The last one is obscure data lineage, especially when the source data we use has copyright limitation, and then this could potentially lead to some violation. So model distillation is the phase that we wouldn't find it very new right now because of the buzz of DeepSeek. So the distillation means a small model, which could be considered a student, is trained to mimic a larger model, which is a teacher. So synthetic instruction data is commonly used together with adapter-based techniques. And it's possible to use synthetic data to train a student model that is larger and more powerful than the teacher. So why this distillation is mentioned here in the dataset engineering? Because I think to do the distillation, it's also about where you get those data from. So this data could be, as a lot of people still debating and figuring out it, like whether DeepSeek is actually using the data generated by OpenAI or other LLMs to train their model, to train like a smaller model with lower cost, which leads to basically a problem on data set engineering itself. Then, so lastly, we are going to talk about data processing. So this is more related with the traditional data engineering space. So first, inspect. You want to look at your data to see if the examples make sense, and also fact check the responses. The second is you want to deduplicate. This is just not to checking whether the response is 100% the same or not, because could also be similar in some ways, and you can depending on the end task can also be considered as duplicate. Identity reservation with the examples of data which point to actually the same person. So this is also very common, let's say in the job application, where one person apply for the job and say if they want to increase their probability, and then they just they change their name or maybe email address, but the same resume, but that's the same person. So the system could also recognize they are at the same entity. And that's also the example they want to duplicate. Next is clean and filter the data. So we want to remove all these things that is not actually containing useful information, like the tokens and markdown and the HTML tags, because you want the model to following the format that expected by the model, and also minimize the input tokens as much possible. So the summary of this dataset engineering chapter are the following. So dataset design across training phases share the same three core criteria: quality, coverage, and quantity. So definitely you really need to consider these three as a whole, because if you just think about the quantity, and you have a lot of data, but this could be overrepresenting certain groups, so we don't have a lot of coverage, and a lot of low quality data, like garbage data, so the quantity is not good. And if we consider the coverage, but if we have too few examples for these types, even though they are well represented, that's also not meeting the criteria for the quantity. So AI could create realistic, complex data that synthetic data become a practical solution for many use cases. So this is when you want to evaluate whether you could use generative AI to generate the data, to basically augment your training data set. However, this synthetic data must be evaluated to ensure its quality before being used to train the model, because this increases our quantity of data and possibly the coverage as well. Say if certain group is lower, not well represented. Just saying the traditional machine learning world is that we want to check the distribution of different groups, and say if the certain group is not well represented or uneven, then this will lead to a lot of issues, especially in the classification model. Then we want to resampling on the data, which is similar idea here on synthetic data. So lastly, and I think that the most important point here is that lots of the things you cannot be allocated and outsource the task to AI. No matter how the AI gets more advanced, you would want to spend a lot of time to think through what data you want, create allocation guideline, and also pay close attention to the data details, basically to really read those data manually and spot any issues, and also can think about whether it basically meets the criteria, quality, coverage, and quantity. So that's all up for this chapter. Let me stop sharing. Any questions? Yeah, no problem. So just a recap. So about this chapter, I think you can consider as a follow-up on the previous chapter on fine-tuning. Because on the fine-tuning last chapter, we talk more about the techniques, like the parameter efficient and also different base models, the model training. But just like in machine learning, is that the creating the data set is also very important and have a lot of nuances. So this chapter is particularly about curating the data set for fine tuning. I don't think this is about, like, say, for prompt engineering, because even so in prompt engineering, we need to have the data pipeline and to make sure the input data is consistent and high quality. But these are more just like smaller examples, because we just say sending one data stream each time to the ARM. Versus here, we want to have like large number of the training data to fine-tune a model. So that's why we talk about the criteria, where to find those data, and how to evaluate their quality control. Things like so basically we can use AI to generate the new data and how to acquire the data, as well as how to make sure that the data actually will be helpful for the model to achieve our end task. So these are the main focus of this chapter. And also, I think this is also a interesting chapter. Let's say if for anyone listening interested in the data engineering career, because when I was working on the data engineering for the past few years, usually DE would support the team doing business intelligence application, or maybe the application would be the machine learning applications, right? So you will do the data engineering to transform the data, the input data, on a regular basis, and so that the data could be used for, say, training supervised learning or supporting the BI applications. But now, more and more, especially say at OpenAI and Soptic, or definitely at Google and Meta as well, they have a lot of, at least I saw in the past, they have a lot of data engineer hiring specifically to curate the data set, which is also a very interesting new domain area. Is that if you want to get into the game of building the new models, it's not like everyone needs to have a doing AI research on how to make the model better itself. But on the engineering front, there are lots of new challenges. One challenge here is the data set, is that how to help the company curate and format this high quality data set for training the large language model, which I think is very different from BI or the machine learning applications. So on the footnote of the book, the author also mentioned this. On the OpenAI, the GPT-3, they only have give the credits like to maybe just 2 of the people on the team, especially on the data curation, data set curation part. But then in the later model, it has like 8 people on the team, specifically on the roles on basically creating the data set for training that model. Which you can see, definitely there are more and more people needed who know how to curate the data set and do this high efficient engineering to help the ALM team to build the model. And also, if within the company, on the application side, when the company need to fine tune the model, or even I think actually there's something this chapter does not cover, but also could be interesting topic to be covered more in details is about the data set for RAG or even agents, especially the RAG, because RAG is also a data intensive application, right? Because definitely in the past, when I found was machine learning engineering interviews, there are a lot of interview questions specifically about the vector database when you build the RAG applications. So similar to machine learning, basically how you want to regenerate these embedding vectors, and how to monitor the performance, and how to measure the latency, and basically how you basically kind of convert the raw data to embedding, what formats to use. So these are all more similar topics as in this book, but more specifically for RAG application, because I think maybe when this chapter was written, fine-tuning was still very popular, like say 1 year ago or something, but definitely now RAG and agents seem to be more popular than fine-tuning. So I think maybe more trend and topics could also be discussed further, specifically on the dataset engineering, like not just the raw data, the prepared data for training the model, but also how you also need the step on converting this data to embeddings, or different ways to store the data as well. Because these data are huge amount. If you think about OpenAI, basically have all the web data. So how you can store this data efficiently, like either like data lake or if you want in the database, and also how to label this data more efficiently. I think these are all very practical topics where the industry is still figuring out. Yeah, so these are just 2 cents on this chapter. Andia, do you have other questions? Yeah, feel free to put in the chat. Yeah, no problem. Yeah, so we have 2 more chapters and a reminder. So next week, we are going to talk about model inference and optimization. So essentially, you have your curated high quality, good coverage, and good quantity of data, and you train a model you like about it, and then how you can serve the data to users. Because say, well, one benefit of using OpenAI or Gemini is that you can just call the API and you can expect it to be really low latency unless their system is down, because they have the very good infrastructure to support their API to like handle at least millions of the requests per second, let's say. But when you do the you have a fine-tuned model, how you can store it and to serve the model to your users, so that they can also have a pretty good experience, say on the enterprise use cases, or maybe if you want to have as a startup model as a service even. then you also, this one could also be more important as well. So that will be the next chapter, and the last chapter will be more on the general architecture and the system design of the AI engineering as a wrap up for the previous chapters as well. Yeah, so yeah, feel free to read the chapters ahead, and yeah, we are very close to finish all the chapters here. Okay.